Alright, Chapter 3, Problem 61. A sandal is dropped from the top of a 15 meter high mast, ship moving at 1.75 meters per second, due south. Calculate the velocity of the sandal when it hits the deck of the ship, A, relative to the ship, and B, relative to the stationary observer on the shore. So, on the ship, the ship is moving along at 1.75 meters per second. On the ship, the sandal appears to fall straight down, right? Because we're not taking, the sandal is also moving with the ship at 1.75 meters per second, right? So the ship is moving with the sandal, and the sandal does this. So from the shore, it looks like the sandal makes a curve. From the ship, it looks like it goes straight down. All right, relative to the ship, how calculate the velocity of the sandal when it hits the deck? Okay, so let's start with part A with figuring out how long it takes for it to hit the deck. Right? In Y, we're looking at 1/2 A Y T squared plus V naught Y T plus Y naught. All right. We're going to make life a little easier for us because we're going to say well, doesn't matter. All right. So initial position Y naught is 15 meters. Initial velocity V naught Y is 0, right? And our acceleration is minus 9.8 meters per second squared, right? So we stick all this in. Oh, yes. And when it hits the deck, Y is 0, right? When it hits the deck, Y is 0. So you stick all this in, we have 0 equals minus 4.9 meters per second squared, T squared plus 15 meters. And so we're looking for T squared equals 15 over, I'm sorry, that's a 4.9. T squared is 15 over 4.9, and that is seconds squared if you work through all the units. All right. All right. So what is T? Equals square root of 15 divided by 4.9 is 1.7 seconds. Sorry. T is 1.7 seconds. Okay, so now we know how long it took for the sandal to hit the deck. Now we can turn to our velocity equation in Y. Vy is AYT plus V naught Y, right? Again, V naught Y is 0. We know what AY is, so Vy is a minus 9.8 meters per second squared, right, times 1.7 seconds. So Vy is minus 9.8 times 1.7 is minus 16.6 or minus 17 meters per second. Right? Vy is minus 17 meters per second with respect to the ship. Right? All right. What is the velocity of this relative to a stationary observer? All right. So for part A, because the ship is moving with the sandal in X, we're not worried about the X component because the X component relative to the ship is 0. But relative to someone on the shore, it's not 0. Relative to someone on the shore, it's 1.75 meters per second. Right? So someone on the shore sees it hit as a vector quantity, right, with 1.75 meters per second in the I direction, the X direction, minus 17 meters per second in the j direction. All right? So the total velocity the magnitude of the velocity is the square root of the squares plus 17 squared. And that's going to be in meters per second. All right. So equals 1.7. I'll just go ahead and do it all. Square root of 1.75 squared plus 17 squared. 17 still. I'll put in the 0.1, 17.1 meters per second. Right? And the direction that it's going at. So it's going down 17 meters per second, and it's going this way 1.75 meters per second, right? So if you're looking for the resultant direction, if we want to say relative to the horizontal, right, then we're talking about an angle that is the inverse tangent of this side divided by that side, the y component divided by the x component, right? So the direction in this case, theta, equals the inverse tangent, the y component, right, minus 17, divided by the x component, 1.75. Okay. Equals a tan of minus 17 divided by 1.75. All right. That's in radians, so we have to convert it over to degrees. So minus 84 degrees. Minus 84 degrees. All right, so 17.1 meters per second at minus 84 degrees. And that's the answer for part B. And we're done with Chapter 3 homework.